All right, well, good morning. We are going to go ahead and get started. With this session, I'd like to introduce David Miller, who is a project manager at Ritu Associates. So David, if you'd like to go ahead and get started.
Great. Thank you. Good morning, everybody. And I'll spend a few minutes here introducing you to civil engineering and what that is. Many people don't realize what is involved with civil engineering. And so hopefully what we talk about this morning will be helpful to you. I would ask, if we were in person, I'd say, how many of you turned on a faucet this morning? How many of you flushed a toilet? How many, maybe not today because of the roads, but maybe in the because of the weather, but probably in the last 24 hours, you've been on a road and probably crossed a bridge. All of those things we do on a daily basis and don't even think about them. But we benefit from the work of civil engineers that design that water and the sewage treatment and the roads and the bridges and whatnot, all those things that we just use on a daily basis. So civil engineering, what is civil engineering? Kind of a dictionary definition. It's the branch of engineering concerned with the design and maintenance of roads, bridges, and similar structures. That's kind of a cold definition. The more personal definition would be the design and construction of facilities that make our society or civilization, hence the word civil engineering, make our society thrive and make it safe while protecting our environment. So you think about those things that we just talked about. We have clean water. We have treatment facilities to clean the sewage. We have roads and bridges that get us from one place to the next. And the role of the civil engineer is to design that so it's effective for people to use and also safe, and more over the last couple of decades, especially conscientiousness about the environment, trying to have minimal impacts on the environment. So all those things come into play. There's a lot of specialties within civil engineering. If you were to go for a civil engineering degree at some point, junior or senior year, you might specialize in one of these: transportation, structural, environmental, that's the water and wastewater, stormwater management, or development, which is what I do. I work in land development, and all of the above is associated with that. So transportation can also be divided up. There's roads, highways, airports, railroads, bridges, and bridges are part of transportation, but they're also part of another branch of civil engineering, which is structural. So you could focus in on structural classes and get involved in bridges, retaining walls, foundations like you see here, steel, concrete, various materials that are a part of structural. Dams are a structural element as well. And you just think about how important this engineering is for the safety of our society. If any one of these things fails, it could be catastrophic. So very important role. This is a project that we worked on in the center city of Allentown. It's completed now, and you drive by and you see the beautiful reflective glass reflecting that blue sky, and it's a beautiful looking building. But I like this picture because it shows beyond that and to the structure of the building. All that steel is designed by a civil engineer, a structural engineer, and it's got to withhold snow loads, wind loads. And then there's just as much structural elements below grade that you wouldn't even see that would hold up in case the earth tremors a little bit, or you don't want it sinking in mud. All of those elements go into structural engineering. Very, very important. So there's the transportation and the structural. There's also the water supply. So it's finding the source of the water, getting it to a tank to hold the tank, and then distributing that water throughout the service area or the community. Again, that plays into your turning on the faucet this morning and getting water, but it also plays into fire protection. If there's a fire, the fire department needs water to put that fire out. They need a reliable source of that water. So all of that goes into the water supply engineering. And then the treatment on the other side. What happens when you flush that toilet or the water runs down the sink? It does not get discharged directly into the river, thankfully. It is treated and cleaned and sludge removed and treated again, some chemicals added, and then it is discharged into the river, but it's clean. And you think about here in our society, our culture, we are used to having clean water and treated sewer, but there's places around the world that are still lacking that. And disease runs rampant because of a lack of clean water. And so civil engineering is something that's needed, not just in the United States locally, but around the world as well. Stormwater management is another component. You get a big rainfall, and what happens to that water? Well, hopefully not that. That is definitely what we want to avoid. And going back to this screen, this is just a very small component of stormwater management. Essentially what we do is we collect the water that runs from a source, and then we slow down the rate of the discharge. Not only slow it down so we don't have flooding, but we also implement means to clean that water. So back in, the most common element, you have a road, that water runs into a drain, into a pipe, and then it's out. But more and more, we're getting into these creative best management practices where the water would actually flow over a depressed curb, run through this vegetation, which filters it and cleans it. And there's soils in here that collect all that, the silts, the grime, the oils. That's collected here before it goes into the storm sewer and out. So all of those things are components of civil engineering. Going to look at a few projects today. This is the crossings at Conestoga Creek. You may or may not recognize that name, but I think a lot of people recognize the Wegmans that opened up, I'll say 3 years ago or so. And so this is the development containing the Wegmans. There's a movie theater up this way, Miller's Ale House, Starbucks, might be familiar with. All of those components within this development. This is Longs Park over here to the east. The Park City Mall is up here in the northeast, just to orient you. This development consists, it's called multi-use. It consists of retail, which is this area here. There are high-end apartment buildings here on the west. I think 259 units with a clubhouse. And then there's a Marriott up here on the hill. So we've got retail, residential, hospitality, and all. That's why it's called mixed use. You may remember a Toys R Us here on this site. That closed down when they went bankrupt, but now it's being converted to a Penn State Health pediatrics facility. So development is not just tearing down buildings and building new. Sometimes it's repurposing and finding a new updated use for existing facilities is there. We'll talk a little bit about just the background here, this is the little Conestoga Creek running from the north to the south. There's another small stream that runs from Longs Park over. And this is a trail system that was constructed to connect an existing trail system to the west all the way over to Longs Park. Close to 2 miles long, I believe this trail network is, and a lot of environmental work that was done. We could talk some more about that. Now, this is a blow up of part of that plan that you just saw. And I don't want to disillusion anybody. A civil engineer does not create these color plans. That's not what we do. There are people involved in graphics. There are landscape architects that make this pretty picture. This is what the client sees. They want this to happen. And but it's up to the engineer to design that so that it can happen. So this is a blow up. This is the Wegmans. These are some of the apartment buildings. On the graphic side, this is what the civil engineer does to make that happen. Here's the Wegmans. Here's the apartments. You see this plan. It shows this is the sanitary sewer in green. There's a water system in blue. I'm hoping that you can see it. There's gas, there's stormwater collection, all those infrastructure that no one sees, right? They're buried in the ground, but yet without that, this development would not function. This is a stormwater basin. We talked about stormwater management. This here is wetlands. We protect wetlands. We work around the wetlands. And we also created wetlands on this site to enhance the ecology and provide habitat for native species, native critters, that type of thing. All got involved with this project. This right here, down here in the corner, this was an old farmhouse from the 1700s. And rather than just knock it down and build something on it, we preserved, I say we, the developer, the engineers, preserved that farmhouse and converted it into an office building. So there's a lot of cool stuff. This here is porous pavement, part of stormwater management, and just a lot of cool stuff going on to make this all work. And then, so the engineer will design this, and then it has to go through several layers of approvals through the township, through the county, through the state. We even had to go through the Army Corps of Engineers for part of this project. So that it's not like you design something and build it. It's you design something, get it critiqued, evaluated, and finally approved. And again, that's that double checking each other. It can get frustrating, but it's a good thing, again, for safety, just to make sure that what we're designing will work. Here's some photos. Here's this is a structural element. We talked about the walking trail through the crossings. There's a retaining wall. This is 22, 23 feet high, and it supports traffic up above. So a lot of structural elements. It looks nice looking wall, but there's a lot of structural elements behind there to make that work. This is the farmhouse from the 1700s that was converted into an office. It's pretty cool. Now, I showed a picture of a bridge in Melbourne, Australia a little while ago. Not all bridges that we design are that sophisticated. This is a pedestrian bridge crossing the little Conestoga Creek. Like I say, the trail network connects the west to the east. And, can we say, well, this is just a small bridge, so we can just kind of slap that together? No, I mean, people are relying on this for safety. You get a storm, you don't want that bridge washing downstream and taking somebody with it. So no matter what you're doing, how big, how small, the engineering is critical. And so you need conscientious engineers working on it. This is one of the apartment buildings. You can see very nice in the foreground here, is part of a wetlands conversion. If you look at, it's not shown in the picture, but if you look to the right, if you're walking on this, you might see white pipes scattered throughout this several acre area, and those are planting seedlings to enhance the wetlands. So when that, again, when that's built out, that'll provide a great environment. This is another project. So we looked at that multi-purpose project. This is a multi-family project that is going through the approval process. This is 600 plus apartment buildings, community center. But along with that, we also did a riparian corridor enhancement and preservation through here, through this stream. This is all planted up, and we're going to be adding some more plantings on there. Again, for environmental protection. This is a storm basin to prevent flooding. And we also did a bridge, really nice looking bridge here as part of the project. So a lot of elements of civil engineering. This is a project that's going to be breaking ground here later this spring. And this is Route 30 along here in the lower left corner. If you're aware of it, this is the Walnut Street ramp, and if you're aware, there's a dead end here. And what's going to be happening is that road is going to be extending to the north, and it's about a mile worth of road, and that will alleviate a lot of traffic congestion on Greenfield Road at this point, and take that traffic away from the existing network. So that's going to be a cool. That also has a bridge, a lot of environmental and stormwater management. Now, sometimes you do get projects like this. This is about 100-acre project and 290 homes, single-family homes that are a part of that. This is for age restricted for seniors like me. So we get into that as well. And then we get into institutional. If you've driven down Route 283, Landisville area, you see the Penn State Health Hospital under construction. And Route 2 is a part of that. And so, again, we facilitate all these important elements of our civilization, hospitals, schools, etc. And then this is in the city of Lancaster. If you're familiar with that, Penn Square, right in the center. This is the convention center, and then there's a Marriott hotel attached to it. We were part of the extension of that 13-story rise, the extension of the hotel. There's a green roof up on the top that facilitates environment, stormwater management. And we get to go through that design and permitting. So I'll stress that we do not do the architecturals, but we do all the site planning, everything that's involved with site, and we coordinate. So focusing a little bit more on the field of civil engineering or the components. If you are interested in this, what are some good things to know? There are a lot of fields that are companions to civil engineering, but you would not necessarily get a civil engineering degree for. All of these things are involved in the projects that I just talked briefly about. So there's survey, geotechnical, and soils. For the structural engineer, he or she needs to know what kind of soil you're building on. Is it going to slide away? Is it rock, solid rock? All of those things. So that's a geotechnical engineer or soil scientist. The environmental and the natural cultural resources, that's the preservation of historical buildings. It's the wetlands, the bog turtles, the associated plantings, all of those things that are environmentally important for the environmental, archaeological even. We did some archaeological work to look for native Indian villages and prehistoric and early American uh, uh, settlements that were on that site. Energy could be oil, could be gas. It could also be the renewables like wind and solar. All of those things we get involved in. Maybe you like the construction. Maybe you like to be outdoors and have hands-on. The engineering, you're going to be mostly at a desk doing drawings. Construction, obviously, you're going to be outdoors, hands-on. So those are things to ask yourself what your interests are. Landscape architecture, those are the not just the pretty pictures, the renderings that I showed you, but it is plantings, it's parks. Uh, Talk a little bit more about that. CAD designer, if you like working with CAD, architects, and community planners. I'm not going to go through all of these, but each one of those paths would, if you're interested in any of those, then there would be a related path for education. Bachelor's in civil engineering or an associate's in civil engineering. We'll talk about a little bit more about that, or survey, all these other fields. Or if college is not for you, and that's fine. There's a huge need in the trades. So, for example, right by Hack, there's if you go to Hack in Lancaster, you drive by High Steel. They're always looking for good people to work in their plant there. There's High Concrete, there's welding, there's all sorts of elements that get involved in the overall product. This is a photo of, this is something that a landscape architect would do. So if you're not into pipes and foundations and all of that, and you like more of this type of thing, then you might want to look into landscape architecture, landscaping, hardscaping, those public facilities like that. So career opportunities in civil engineering, if you're interested, there's kind of break it down between two. There's the private sector and there's the public sector. Private sector is a consulting engineer like what I do. You could also work for a developer, and I'll just say like a Sheets. They have that they're building facilities and growing their businesses. They have engineers on board that work for the company and that work with the consulting engineer, or the energy producers as well. All of those part of the private. Public sector, you work for the government. Essentially, it could be the municipality, the township, the city. Public works, they're the ones that maintain roads, water, sewer, and you could and plowing the roads, putting salt on the roads when you have ice storms. That's public works. PennDOT always has jobs available. DEP, that's the Department of Environmental Protection, and even up to the federal level, the Corps of Engineers. So a little comparison between the two. Private sector, which is what I am part of, which the consulting engineer. So in the private sector, this is a very general. Wages are usually higher than in the public sector, but you also work more hours. There's more stress, more intensity with the deadlines. You're working for many clients. They all have needs, demands. So it is quite intense. And then, but you also advance through your effort and through your interests. So as high as you want to go, you can go. You put that effort in, find something that you really enjoy doing, and you can advance at your own rate. And I would say, just for reference, like if you graduated from a 4-year college and you were an entry-level engineer, then you might start, I'm going to say, in the neighborhood of $60,000. 60, not 16, 60. If you look at the public sector, I say routine, the work days are generally more consistent. Work schedule, sometimes the benefits are higher. Like you get more vacation time, retirement benefits, healthcare benefits are usually higher in the public sector. Your wages and your advancement are not necessarily based on your effort, even though it is, but you have to go through testing as well to advance. So let's just say you're working at PennDOT and you're level C1, and you want to go up to C2. Well, you have to wait for PennDOT to offer a test for that. You may have hundreds of people taking that test, and a certain number are selected from that. So it's more competitive from that standpoint. But again, either these are great areas to look into. I'd encourage anyone to look into both and see where their interests are. I'm going to guess that someone coming out of school, going into the public sector, like PennDOT, maybe you're starting at 45,000, something like that. All right. A day in the life. What do we do? We solve problems and we meet needs of our client, and not just our client, but the townships, the communities. There's issues, we try to solve them. There's flooding, we try to solve it. There's a transportation bottleneck, we try to solve that through engineering. So as a team, we do these things. Personally, you never stop growing and learning. I've been at this for 30 plus years and still learning things, better ways to do things, new technologies, my personal skills, even working with people, patience, all those things get tried. And so you push yourself to grow. Interacting with coworkers, clients, stakeholders, you learn those personal skills. Business opportunities, you work under a schedule, budget, you work on multiple projects at the same time. You don't sit at a desk and work on one thing for days and days. That's the one thing I've said many times about this, is no day is ever the same. No project is ever the same. You will not get bored in civil engineering. Success, this is an alpha. It's the best I could find for if you have seen that in math, that's the symbol for directly proportional. So your success is directly proportional to your effort. Career path in civil engineering. So what would you do? Right now, you're in high school, take as many technical and STEM classes as you possibly can. Science, technology, engineering, and math. Several things that increases your proficiency in those areas, but also you see if that's an area that you're interested in and if that's something you want to utilize throughout your career. So find out now in high school rather than 4 years later after college, where your strengths are, where your interests are. Shadow an engineer. I've got my kids, I tell them, I said, find somebody that does what you're interested in doing and shadow them for a day. Walk around. This 45-minute presentation is glossing over so much. Find out what they really do on a day-to-day basis. Look at their plans, look at their routines, and then find out, is that something that appeals to you? Choose a college that matches your interests. That may seem obvious, but how many choose a college because it's popular or because it's where your friends are going? That's where your boyfriend's going, your girlfriend's going. A lot of bad reasons to choose a college. the best reason is find one that will prepare you for your future, because once you, well, even now, you are starting to prepare for your future. Take it seriously. Look into trade school through a trade school or apprenticeship, is a certificate or a 2-year or 4-year degree. What is it that's going to take you where you want to go with your career? Find out those things as early as you can. When you're in college, participate in internships, working for a company that does, or companies, get as much experience as you can, and to further develop what you want to do, what your interests are. Once you're out of college, you can take your fundamentals of engineering exams, like a precursor. EIT is engineering training. And then after at least 4 years of experience, you can get your professional engineer's license and be licensed like I am in the state of Pennsylvania or any other states. Advice, don't be in a rush to advance to management. When we're interviewing somebody, we say, what are your interests? Are you like more the technical side, or do you want to manage projects? A lot of people say, oh, I want to manage, but don't rush to that point. That could be a decade. It could be 15 years before you become a manager. Learn the technical side first of what you do, and you'll be a much better manager and able to do that job well. Continuing education, never stop learning, becoming a part of trade organizations. So you are always growing. Is civil engineering right for me? What are some indicators? Well, office work, like I say, an engineer is going to mostly work in the office. We do get to visit sites and look at sites once in a while, but I'll say 95% of what we do is in the office. Or if you can't stand working in office, you feel like you're penned in and you get restless, maybe something that along the lines of field work would be of more interest to you. That would be surveyors, geologists, anyone that's working in the field. Just remember, a surveyor, yeah, they're out there in the spring and summer and fall, but they're also out there on the 10-degree days in the winter. So just be aware of that when you're making your decision. Absolutely critical, have a team environment and attitude. A good test for you now when you have your school group assignments, how do you interact with your fellow students? Do you take leadership? Do you take it seriously? Do you go the extra mile to put a good product out for your teacher? Or are you the one that sits back and lets the rest of your team do the work? I mean, that can change. You can always mature and grow out of that, but that doesn't change. Those group settings, you're going to be part of a team environment your entire career. Problem solving, do you like solving problems? Or I like to say, finding solutions to challenges. Not everything is a problem, but there are a lot of challenges out there that detail-oriented, engineer, artistic, maybe more the landscape architect. What are your, which way are you bent there? Might guide you. Patience and perseverance, always. I mean, that again, that grows with time, but if you say, I want to do engineering, I want to develop something like the crossings there that I showed you. That took 3 years for us to go through all the engineering and design. And that project itself, in various forms or fashion, was actually ongoing for 11 years, plus or minus. It started, it stopped with the economy, all that. But once we really started on it, it was 3 years worth of engineering and approvals. It's not like something, if you like to build things, you get it done, and you're done. This is not that way. So again, take that into account. Curiosity. If you find yourself with a curiosity component of your personality, then maybe engineering is right for you. And what do I mean by that? Well, so this is that pedestrian path under construction at the crossings. And let's say you walk by there now and you see a bunch of rock piled up against the bottom of the wall. Does that stoke your curiosity? You wonder what that's for. You'll see some pipes sticking out through the wall. Do you walk right by it, or does that catch your eye and you say, I wonder what that's for? You're at the crossings, you see two different colors of pavement. Does that catch your eye and you wonder why that is? Was it just a bad paving job, or is that the way that is that intentional? Do you ever walk down a sidewalk and wonder what's beneath your feet? Especially in a downtown city environment, there's lots and lots of stuff underneath the sidewalk and in the roads. You ever see a hole and you look into it to see what you can see? This pipe is running through a park under the stream and out. This was just a couple of years ago, I want to say, park in Millersville, and it caught my eye. I didn't know what it was, but still, all the years in the business, I was curious as to where it went. So I followed it and, notice how the pipe size changed. And do you wonder how can anything flow uphill and then down across the creek? How does that work without a pump? It does. If you're curious, you might ask yourself those questions. So I'm not going to answer all those things. I'm just saying it's a good check for you and your curiosity. On my path, I'm just going to go through this really quickly. I actually have an associate's degree in civil engineering technology. And my bachelor's is not in engineering, but I went, that has been my career. And so I just grew through the system and through hard work. And I actually stepped out of engineering, and as part of a school administrator, I actually got to teach STEM classes, which was really cool. But just working my way from a CAD designer to a project manager, and now I oversee project managers. The one thing I do want to point out is that the civil engineering technology, if you go that route, this is what I thought I wanted. And when I realized I really wanted to get my license, my engineering license, needed a 4-year degree to do that. I found out that most of my technical classes did not transfer from the associates to the bachelor. So I ended up kind of having to start all over again with the sciences, the maths, the technical classes. So I did that while I was married, kids, Penn State, Drexel University, and the work and family responsibilities just got too heavy. And so I discontinued. I did not finish my bachelor's. So if I had to do it over again, that'd be one thing. I would go straight for the bachelor's degree. Not that I have any regrets, but I was able to get my EIT and my professional engineer's license just through self-study and hard work. So I would suggest, again, we talked about it, seriously consider that before you take a civil engineering technology or any associate's degree. Make sure the credits transfer. Day in the life, you would start out with setting up some drawings, then you get into the design level, and then you get your license, you become an engineer, and then project manager, and you get out into the public more as a project manager, presentations, managing staff. So I won't take the time to go through all of that. What was it about me that got me where I am? I always enjoyed seeing construction. My parents laugh. They tell me when I was 4 years old, we would drive by a road construction site, and I apparently said that I didn't want to be like my dad. I wanted to be a worker. And by that, I meant I didn't want to work in an office. I wanted to do construction. I've always enjoyed construction. I'm one of the weird ones that when I first got my license, instead of avoiding road construction when I'm driving, I would purposely go through it to see all that was being done. And that was pretty cool. So I like construction, always have. Problem solving, challenge meeting mindset. I don't settle for good enough. I'll rack my brain to find the right solution that I'm happy with. Commitment to deliver, strong desire to learn and grow, always looking for ways to improve. I've always listened to people. I've never been a know-it-all. I appreciate other people's insights, and I respect everybody. I do my best for that in lots of hours. So that's what got me to where I am. And I think that's a typical path. So going back to our definition, what is civil engineering? There's the technical definition of what we do, but then there's also the personal element of how we are helping our society, helping our community to thrive and to be safe, and protecting our environment. So that is that, and we have just a couple minutes, looks like, if there's any questions.
If anyone has any questions, please just type them in the Q&A box in Zoom and we will answer them. I did just put a little chat out to everyone that as David was talking about the credits transferring, that is definitely really important to look into first for your programs. And the associate program at HAC for the engineering, so there's different associate programs, but the engineering associate program, those credits do transfer for a bachelor's degree in civil engineering. And I put my email in there. So if you do have questions on any of the engineering programs, I'd be happy to answer those.
That'd be great. And my contact information is down here on the screen. If anyone wants to email me, if you want to shadow for a day, it would be happy to. Now that we're open, offices are open, now we can do a shadowing opportunity if you want to see what we do.
Well, if there aren't any questions, David, thank you so much. That was really a phenomenal overview of civil engineering. And thank you all for joining us today.
Hey, thank you. I enjoyed it. Take care.